Hey guys, I hope you are still good. Today we are doing hyperbolic functions, or you can just call them hyperbolas or whatever you want to call them. But these are functions that are seen by this standard form. So f of x, my handwriting is a bit crazy today, but you see them by this standard form, a divided by x. Since this is grade 10, it's a divided by x plus q. All right, don't worry, we'll talk about what a is supposed to do and what q is supposed to do. I'm sure you are now familiar with f of x and x, because f of x is the same as our y, and then this is just our x. So a and q, don't worry about them for now. I will explain later what they are supposed to do. All right, but before we even talk about the q and anything else, let's start with a very standard, very simple hyperbolic function. So this will be f of x is equal to 1 over x. So now this means I've replaced a as 1. Do you see that? My a, like there was an a above the, in the numerator, and then now we have 1. I'm sure you can see that. So we're just in this video, because I believe it might be too long. So in this video, we'll just be talking about 1 over x, and then you'll see what 1 over x is doing. And when we try to sketch 1 over x, you'll see where it cuts, where the domain is and where the range is and all that stuff, right? So yeah, don't worry about q for now. We'll talk about q later. Right, so I felt compelled to first remind you what a function is, right? So in this case, let me first remind you what a function is supposed to do. So let me just change my pen real quick. So if you remember, let's say grade 7, 8, 9, probably, you were doing something like this, where you would have something in the middle. Let's say in this case, let's say we have 2x, right? So inside the box we have 2x, and then you are told that you are going to put, let's say, 1 here and then 2 here, as well as 3. So in those lower grades, you knew that where there is x, you were going to put the numbers that are on the left, right? So all these numbers will be replaced. Will replace x. So which means if you wanted to get an answer of this part, you would say 2 times 1, and you would get 2 here. And then to get an answer for this second arrow, you would say 2 times 2, and then you would get 4 here. And then to get an arrow for this, the answer for the third arrow, you would say 2 times 3, and then that would be 6, right? So this is what a function is. So when we talk about functions, this is basically what we are talking about. We are talking about inputs. As you can see, this side we have inputs, and then inside the box, that's where the process happens. So I would say processes, and then here we have the outputs, right? So this is your outputs. Right, so think of this as a bakery. Let's say you are baking cakes. This means this side of the inputs, that's where you would have your flour, your sugar, whatever you use to bake cake, right? And then in the processes, that's where you would have the oven burning the flour and all that stuff, whatever happens when you are baking a cake. And then at the end, your output would be the cake itself. So this is a picture of a cake, hopefully. This is a picture of a cake. This looks like a hat. Don't worry about that. But this is my cake, right? So you would have a cake here, and then here you would I would say stuff that happens in the oven. So the cooking, the baking, and all that stuff in the oven. And then here you have your ingredients. I'm not sure if I can spell ingredients, but whatever, you know what ingredients are. So you have your flour, you have your stuff that happens inside the oven here, and then at the end you have the cake, right? So that's what a function is. You are getting inputs from outside, and then you're processing those inputs, and then you are giving us an output, in this case 2, 4, 6, or this cake that I drew. All right, I hope that will jog your memory on what a function is. This is basically what a function is. And then now let us try to understand what a hyperbolic function is. Let me erase this stuff. All right, so like I said, in the processes, that's where we have something. In this case, since our function is f of x equal to 1 over x, that means that's where we are going to have our 1 over x inside the box, right? And then our inputs can be anything. Our inputs can be 0, can be negative numbers, and then we'll see what happens when we input 0 in this case, right? Actually, let me just include that as well. Let's start from, let's say -1 here, and then 0, because I want you to see something. I want you to see what happens when we insert 0 inside this function, and then we'll get our outputs. So now, to get our outputs is very easy. Let me just rewrite this. Inputs. To get our output is very easy. We just take x, because this is our x, right? Our x is our input, and then our y, or our f of x, is our output, right? So what comes after? In this case, what I'm saying is, to get our outputs, we're just going to replace x with a respective input. So in this case, for -1, that means it will just be 1 divided by -1, and then our output would be what? -1. So which means this arrow would be -1. All right, and then what happens when we now want an output that is related to 0? So 1 divided by 0. What is going to happen when we divide by 0? This will be undefined, right? So I would say undefined, which means there is nothing, that there is no output for an input of 0. So I'll just leave a box there to show that there is nothing, right? And then when it's 1, we'll just say 1 divided by 1 is equal to what? Is equal to 1. I hope you can see that. And then you can continue with this process by inserting 2, by inserting 3, by inserting 4. By the way, if you insert 2, what's going to happen? You're going to have 1 divided by x, which is 2, and then you'd get half, so which is 0.5. Which means if we continued and say 0, 1, 2, 3, 4, we would have those answers like half, 1 over 3, 1 over 4, 1 over 5 as our outputs. Do you see where I'm going with this? All right, so to show you a diagram of this and what a 1 over x function, or a basic hyperbolic function, is supposed to look like, we'll go and use this software called GeoGebra. Let me show you right now. So we're going to use GeoGebra, and you'll see what happens. So GeoGebra, it helps you to visualize the stuff that you are building. So let's say you're building a function, a quadratic function or a linear function. Then if you type in the function itself here, it'll show you what's going on, right? So in this case, we want 1 divided by x, and then you can click enter, and after that you can see what a hyperbolic function is supposed to look like. So if you see, now look at what happens when x is 1, because this is our x-axis. I'm not sure if you can see my cursor, but if you look at our x-axis, when x is 1, do you see 1 there? Y is also 1. Do you see that? So when x is 1, y is also 1. And then what happens when x is 2? When x is 2, you can see that y is half. Remember when I said 1 over 2 is the same as 0.5? This is where we are seeing that. So if you look at that, then you can see that when x is 2, y is equal to 0.5. And then you can also go to the negative numbers. You will see that when x is -1, in this case, when x is -1, look at when x is -1, you get that y is also -1, right? And then when x is -2, you get that y is -0.5. Do you see that? And then now there is something special that happens when x is 0. Look at what happens when x is 0. So look at the cross. I'm not sure if the cursor is showing, honestly, but if you look at where the x's cross each other, so in the middle, so that's where x is 0. Do you see that we don't have a function there, right? We have nothing when x is 0, because when we divide by 0, so 1 divided by 0, we said it's undefined. So we will not have a function when x is equal to 0. Do you see that? So we can try other things. Remember when I said the number that is above, that is at the numerator, that is our a. So let's see what happens when we change a. We're talking about a being 1 as our standard function. So let's try changing 1 and let's say 2 and see what happens. So when we say it's 2, do you see that our function is expanding? Do you see that? Like it's going away from the center. Do you see that? So now let's try 3. 3. Do you see that it's also expanding? So I'll just zoom out like this. I want you to see properly. All right, so let's increase this to 4. I want you to see what's happening when you increase a. So we're increasing a. Do you see what's happening? So 4 is just increasing a little bit, and then let's insert a dramatic number like 10. Do you see that now the gap between the center and the graph itself is increasing? But what happens if a is negative? I want you to see what happens when a is negative. All right. So if a is negative, actually let me take a screenshot of this so that I can go and talk about something else on that other software. So before I enter the negatives and everything, I will take a screenshot and come and paste it here. All right. Now let's try when a is negative and see what happens with the function. So -1 in this case. Now look at this. Now when a is negative, do you see that our function shifts? It was on this part, it was here and here when a was still positive. But since a is negative, it shifted to having to existing here as well as this side. All right, I'll also take a screenshot of that and then we'll explain why that happens. Let me just give me a second. The thing is, when a was still positive, this was 1 over x. So I want you to notice this. So when a was still positive, so this was f of x equals 1 over x, but a was positive, right? So positive, a greater than 0, this means a is positive. So our function was in this quadrant as well as this quadrant. All right, we'll talk about quadrants like in a minute. And then when a was negative, so this was -1 over x, so f of x was -1 over x. When a is negative, a less than 0 is negative, then our graph now lied in this quadrant as well as this quadrant. All right, I hope you can see the pattern. I hope you can see what is happening. So now let's talk about quadrants, because I feel like you also need these quadrants when you're doing stuff like trigonometry. You need to know what a quadrant is. All right, so it's something that you need to know. This is your first quadrant, so I'll say first, and then this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. All right, so what do you see? When a is positive, our graph exists in the first quadrant as well as in the third quadrant. Do you see that? So when a is negative, you need to remember this rule. When a is positive, our graph lives in the first quadrant as well as in the third quadrant. This is one of the things that we need to know. And then when a is negative, what happens when a is negative? Well, our graph lives where? Our graph lives in the second quadrant. This is second quadrant, and the fourth quadrant. So what I used to cram in my head is that if a is negative, then the quadrants are even. Do you see that 2 is an even number and 4 is an even number? So when a is negative, then I would say my graph lives in even numbers. And then if a is positive, my graph lives in odd numbers, because 1 and 3 are odd numbers. So you can try to put that in your head, and then maybe it will make sense. All right. So when a is negative, we have our graph in the second quadrant as well as in the fourth quadrant. And then, as you can see, there's something special that happens when x is 0. There is no graph at all. Like if you go down, there is nothing at all. Do you see that? There is nothing, because when we put 0 in the denominator, our function breaks. We get an undefined answer. So that's why we don't have a function. That's why it actually goes up and down like this, because it's trying to not be 0, because at 0 there is a disconnect, or there is an undefined answer. I hope that makes sense. So now let's try talking about domain and ranges. All right, so let's talk about domain and range. This is your fourth quadrant. Okay, I shouldn't erase this. Let's leave it like this, because it's something that I need you to know. All right, so first let's talk about domain. Right, so domain, what do we mean by domain? So this is your x, and then this is your y axis. When we talk about domain, we are talking about where the function touches in terms of the x-axis. So where does the function touch in terms of the x-axis? Do you see that? So as you can see that our function exists when x is 1, when x is 2, when x is 3, when x is 4, when x is 5, because look at this. It does exist when x is 1. It does exist when x is 2, because it goes down like this. It does exist when x is 3. It also exists when x is 4, when x is 5. Do you see that it exists on almost all values of x? And then when we come to the negative side, we do see that the function exists when x is -1, when x is -2, because you can jot it down like this, and then when x is -3, when x is -4, and then when x is -5. And you can go on and on forever up until negative infinity. This is negative infinity. You can also go on up until positive infinity this side, without actually finding a point that x doesn't allow. But there is a special x value that doesn't have a y value, and that is 0. Do you see that? Do you see that when we are at 0, there is no corresponding y value? There is nothing. Like, we don't have the green graph touching the 0 part, right? So this means that our domain is, well, we are moving from negative infinity up until positive infinity. So we are moving from negative infinity up until positive infinity. But when we get to 0, we don't have anything. Do you see that? So we do have a graph from negative infinity up until positive infinity, but when we get to 0, there is nothing. I hope you can see that. So our domain is just that. We'll just say, okay, our graph exists on all real numbers. So this is what it means. So our graph exists on all real numbers. So x is an element of all real numbers, but x cannot be 0. All right, so that's what this means. So our x exists on all real numbers. So your -20, your -15, your -10, your 10, your 5, your thingy. But when we get to 0, there is a disconnect. Do you see that? And then now when we go to range, we talk about y values. Our domain, this is all about x values. All right, and then our range, here we talk about y values. We don't look at x values when we are talking about range. We're looking at the y axis when we are talking about the range. So let me erase this real quick. All right, so when we talk about the range, we look at the y axis, which is this. All right, so we are going to see that, okay, there is the graph exists when when y is equal to -1, because you can see that the graph is here. And then when y is -2, we do have a graph here. -3, this is the graph. -4, the graph exists. negative 5, the graph exists, and you can continue forever up until negative infinity. Do you see that? And then we come to the positive side. We see that, okay, when y is 1, there is a graph here. When y is 2, there is also a graph here, graph there. When y is 4, there is a graph, and then when y is 5, there's also a graph. And as well, you can continue up until positive infinity, because as you can see, there is something for that, for each and every positive and negative. But like we said, we do not have anything on the y. Remember when we were talking about x, we said when we put 0, we don't have an answer because it's undefined. So you can also see that when you look at our function through the y perspective, there is also no x value related to y being 0. Do you see that? Like, we don't get the green graph here. Like, the function doesn't touch this part. So there is no y, there is no x value that is related to what? To y being 0, which means our range is also y element of all real numbers, but y is never 0 because there is no y value that is related to the graph. Do you get what I'm saying? So yeah, I hope this is making sense. I hope this is making sense. If it doesn't make sense, you can put you can leave a comment down below, and then I'll try maybe to explain further. And then let's see if we can find an example from the textbook. All right, so now let's try this exercise or example from the Everything Maths Siavula textbook. All right, so if you pause, you can pause this video and then try to solve some of these questions yourself, but we've already covered most of this stuff already. All right, so I assume that you've paused and unpaused, right? And then now you will just do it together. So now we have this function, because this is the function that we've been working with, so 1 over x, and we are told that the general form is a over x plus q, just like we said. So this is the one that we were working with. We want to see if we can answer this question, right? So complete the following table for each of x is equal to 1 over x and plot the points. When you're looking at this, what do you remember? What do you remember? You remember this this thing that I showed you, right? Remember this function thingy that you put 1 over negative 1, you get negative 1, you put 0, you get 1 over 0, which is undefined, and then you put 1 where there is x, and then you get 1 over 1, which is 1. So this is just the same thing. It's just that they are using a box. All right, so you just replace x in the function h of x. So they are using h of x here. So h of x is equal to 1 over x. I mean, this is x. So since this is our x, which means this is our input and this is our output, they just don't have the processes part that we had on the other side. So to get our output, we know that we put x here, right? So as you can see, 1 over negative 3, this is the same as 1 divided by negative 3, and then we get this answer. All right, which means this will be 1 over negative 2, this will be 1 over negative 1, which is negative 1, the one that we got the other side. And then if we have half, this is the same as 1 divided by negative 1 over 2, which is the same as 1 times negative 2. All right, so then we get negative 2 here, and then I'm sure you can see the pattern here. We'll get negative 4, and then here it's undefined, so I'll just put an x, and then here we will get a 4, and then here we get a 2, here we get a 1, here you get 1 over 2, right? I hope you can see this. And then here you get 1 over 3, right? So it's just a mirror of these answers. So negative 1 over 3, we get positive 1 over 3 here. Negative 1 over 2 here, we get positive 1 over 2. Negative 1, we get positive 1. Negative 2, we get positive 2. Negative 4, we get positive 4. And then we have an undefined answer here. All right. Easy enough. And then they say join the points with smooth curves. We don't necessarily need to join because we've already done this. This is what we did. We used this software to join. So you can draw yourself and then try to join. But this is the graph. All right. And then let's go to the next question. They're saying what happens. Okay, we are done with number 1. They say what happens if x is equal to 0? What happens when x is equal to, what happens here? Well, our graph is undefined. So graph or h of x is undefined. So undefined here, because when you divide by 0, you always get undefined answer. And then explain why the graph consists of 2 separate curves. Why do we have 2 separate curves here? Why do we have 2 separate curves? Why do we have one in the first quadrant and the other one in the third quadrant? Try to answer yourself. Because when we get to 0, our graph splits. Remember, when we get an undefined, our graph decides to split. So if there wasn't an undefined here in the middle, our graph would just continue like similar to, let's say, probably an exponential function. We'll talk about exponential functions later. But since there is a divide here, like there is a split, our function then has 2 quadrants because of this undefined area. You get what I'm saying? Let's try answering the other one. What happens to h of x as the value of x becomes very small or very large? Now let's look at that. What happens to the function when x becomes very small or x becomes very large? So this is our x-axis. Let me just erase some of this stuff. Okay, so they're asking, this is when x becomes very large. So going that side, we are going large, and then when we go to the left, we're going like small, right? Because it becomes negative when you go this side. So going that side to the right, x is becoming very large, and then going to the left, x becomes very small. So they're asking what happens when x goes to the right and what happens when x goes to the left. So as you can see, when x is going to the right, look at this. When x is 5, this is your y. What's happening to the function? This is where your function is. And then when x is 10, do you see that the function is getting closer and closer to the x-axis? Do you see that? So it's getting closer and closer and closer to the x-axis, but it never touches the x-axis. It just gets closer, closer, and closer and closer. So it never touches it. All right. And then when it gets very smaller and smaller, do you see that it also follows the same pattern? So when we go to the left, the function approaches the x-axis, but it never touches the x-axis. It just approaches it. It never touches it. Do you see that? So as it gets larger and larger and larger, our function approaches the x-axis, but it never touches it. As well as when it gets smaller and smaller, or when x gets smaller and smaller, our function never touches the x-axis, but it gets closer and closer and closer each and every time. All right. So now let's go and look at the other question. The domain of h of x is this. Remember our domain, x element of all real number, but x is not 0. Determine the range. We've already determined the range. The range is also y element of all real number, but y is not 0 in this case, right? Remember when we were talking about domain and range. And then about which 2 lines is the graph symmetrical? What is symmetry? So let's talk about this one for a second. Although it's negative, but we'll talk, symmetry will be the same. So okay, when we talk about symmetry, we are referring to how can we cut our function such that it remains identical. All right, like how can we cut our function maybe in half or in whatever, and it remains identical? So those parts or those 2 parts are identical. So as you can see that when we cut our function, let's say from here, right, this part is identical to this part, like it's a mirror. It's kind of like a mirror. So this part is a mirror of this part. All right. And then also, if you look at when we cut it through this side, let's say from left to right, again, so let's say we cut it again from this side, then let me erase this one. Do you see that we also get an identical picture? So this side is the same as this side. So this means our lines of symmetry are when we cut our graph this way as well as that way, the one that we just cut. So this is y equal to x, and then this is y equal to negative x. Why? Because as you can see, this is just a straight line, right? So a straight line, when x is equal to 1, y is also equal to 1. When x is equal to 2, y is also equal to 2. When x is equal to 3, y is also equal to 3. So that's why we see y is equal to x. So our lines of symmetry, so let's just see lines of symmetry are y equal to x. This is your first one. And then the other one is, as you can see, that when x is equal to negative 1, y is equal to 1. When x is equal to negative 2, y is equal to what? Positive 2. When x is equal to negative 3, y is what? Positive 3. Do you see that? So which means our second line of symmetry is y is equal to negative x. So those are the answers. So these are the lines of symmetry and the answer to the last question. About which two lines is the graph symmetrical? So our two lines are y equal to x and y is equal to what? Negative x. I hope you consider subscribing and liking the video, and I will see you in the following videos.